So today we are going to solve one question asked in next 2024. This is from mechanics program, and more specifically this is from central force motion program. So basically central force motion is a type of motion in which the force is depend upon the distance and it is independent of any angle, and it only depend upon the distance between the line joining between the 2 points. So what the question tells about: a planet of mass m is uniform circular motion about a star of mass capital M. So one star is there at the center, let the mass is capital M, and another planet is moving in a circular motion having mass small m, and it is given that capital M is very large than small m. So mass of the star is larger than the mass of the planet. Let V, L and R be the velocity, angular momentum and position vector. So R be the position vector, that is line joining between the mass capital M and small m. So V, L and R be the velocity, angular momentum and position vector respectively of the planet about the star. Okay. Then here he has defined that A vector is equal to V cross L. Okay. Then we have to check the following 4 ABCD condition. So initially we can know that the angular velocity of the planet of mass small m about the mass capital M will be angular momentum will be R cross P. So this is R cross MV. Okay, as we know that under the central force motion the velocity of planet will be tangential in nature, so it is perpendicular to the radius vector r. Okay, so it is always in the tangential direction, and the angle between the r vector and V vector will be 90 degree. Okay. So let's solve this equation, that is A vector is equal to V cross, let's put the value of L, that is R cross P. So this is the condition of vectoral triple product. So we can know that A cross B cross C let A cross B cross C is the vectoral triple product. This formula is B A dot C minus A dot B dot C. So A vector can be written as R dot V dot V vector minus V dot R dot product with P. As we know that instantaneous velocity is tangential to the radius vector r vector, so the angle between them is 90 degree. So dot product V dot R V vector dot R vector will be 0. So on solving this equation we can get r dot v, p can be also written as mv, so this is mv. So dot product of this will be give as m v square, v mod square, and this is r vector. So the direction of a vector is along the r direction, so the D option is correct. Let's check another option. So a vector is a zero vector, so this option will be incorrect. So we can find out the magnitude of a vector. So to find out the magnitude of a vector, we can use the condition of the circular motion. Under the circular motion, the necessary centripetal force will be balancing by the gravitational force. So this will be gravitational force G capital M small m by r square is equal to necessary centripetal force, that is mv square by r. So this condition will be given by gm by r equal to v square. So magnitude of v square is gm by r. So this value will be m gm by r, and this is r vector. So the value of a will be gm capital G capital M small m by r into r vector. So this option, B option, is correct. Next we can check the C option. A is the plane perpendicular to the plane of planet of the orbit. So A plane is not perpendicular, it is along the plane of the orbit. So as it is the direction of A, so this option is also incorrect. Only the angular momentum will be the perpendicular to this plane, that is r dot l equal to 0. Okay, you can check that r dot l, this will be 0. So A is along the direction of the plane in which the planet is rotating. Okay, so only the correct option is D. So in this problem we can first find out the necessary condition for which it is moving in a circular motion and putting all these value to get the conclusion. Okay, thank you.